Assalamu alaikum guys, welcome to another experiment. So today we are going to be studying the experiment of determining the horizontal thrust in two-hinged parabolic arch. So a two-hinged parabolic arch is usually an arch in the form of a parabola, not a semicircle but a parabola with two hinged supports. So as you can see in the next slide, this is a two-hinged parabolic arch with certain loads hanging all over. This is an arch, these are the load hangers, this is the sliding support, and this is the dial gauge connected at one end, at the roller end. So in this experiment we are going to be using a mild steel 25 by 4.5 mm section with 600 mm span. Span means from one point to the other. This is the horizontal length, and 100 mm rise. This is the top portion is 100 millimeters high as compared to the bottom portion. So such hangers are going to be hanged from this arch, with another hanger hanging down the pulley at the extreme end of this arch, with a dial gauge placed at the right hand side, and of course a hinge at the left side. So we are going to be studying two types of behaviors in this arch. One is going to be the just due to the horizontal load, we are going to put some load on this pulley, and we are going to find out the displacement on this dial gauge and compare it with the theoretical formula that we are going to be discussing right now. And in the other portion we are going to be studying the uniform load applied here and the amount of load that is necessary to balance it so that the dial gauge reading comes back to zero, so that both these loads balance each other out. So we are going to be studying that also. So horizontal displacement due to horizontal loading only. So the formula is delta is equal to 0.105 W. Delta is the horizontal displacement. For example, if we are going to be putting on some weights on this pulley and no weight on this on the other hangers, just a single weight on this pulley, so it will going to push this arch towards the towards inside, and so there will be some deflection on the dial gauge. So that deflection is going to be measured with the help of this formula, 0.105 W, or W is equal to horizontal load at support, the amount of load that we are going to hang on the pulley. Whereas for uniform load, the amount of horizontal thrust produced is equal to 0.008 W by 0.003, where W is the uniform load applied on each hanger on the parabolic arch. W is the horizontal load, it is the vertical load applied on the parabolic arch. This is this load. This load is called as the W. For example, if you are going to hang 100 grams on each of these loads, then W will be 100. Also, both these formulas are only specifically applicable to this specific set of arch whose span is 600 mm and rise is 100 mm, 25 by 4.5 mm section with the same material properties. So let's suppose for uniform load we have H is equal to 0.008 W by 0.03. So if we are going to hang 1 Newton per meter of load, then the horizontal thrust comes out to be 2.66 Newton. For 2 it comes out to be 5.33. So the experimental reactions come out as follows. For the experimental reactions are 3 newtons, 7 newtons and this is 10 newtons. So for percentage difference, which comes out to be 12.5, 31.3 and 25%. This is actual minus theoretical minus actual divided by theoretical values into 100. This is what percentage difference formula is. So this is the chart. This is how you're going to fill it: uniform load, horizontal load, vertical displacement, horizontal displacement, theoretical vertical displacement, theoretical horizontal displacement, percentage difference, and so on. So this is some sample data. If we only have horizontal load, then horizontal load at support. Horizontal load at support means horizontal load at the pulley, just this pulley, nothing else, just a single load on this pulley. So then what are we going to do? Horizontal displacement is given by 0.27, which is given by the dial gauge. By hanging 2 Newton load, or dial gauge gives us 0.27 mm of displacement. Theoretical horizontal displacement is 0.21 mm, which is given by the formula 0.00. The formula is 0.105 W, like this formula. So the percentage difference comes out to be 28.6%, 31% and 30.2%. This is a huge difference. So now coming to the horizontal load and uniform load, let's suppose we are hanging 1 Newton load on each of the hangers. Each of these hangers are carrying 1 Newton of load. Alright, now we are going to place that amount of load on this pulley, which is going to counteract its effect, counteract the effect of all these loads, so that the dial gauge again comes out to be 0. So that load comes out to be 3 newtons, 7 newtons and 10 newtons, whereas the theoretical load according to the formula is comes out to be 2.66, 5.33 and 7.99. So their percentage difference is 12.5, 21, 31.3 and 25%. So that's all about today's experiment. I hope you are going to be taking some of the information from these videos. If you have any comments or queries, feel free to drop them down in the comment section below. Thank you so much.